saw in our last concept about finding the area of triangles using trig that sometimes trig ratios can actually be helpful even if the triangle is not a right-angled triangle. So the law of sines and the next concept, the law of cosines, are ways that we can use the idea of sine and cosine to find values even if your triangle is not a right triangle. So the law of sines and the law of cosines are on your formula sheet. You don't have to memorize them. But keeping in mind that same thing we talked about last time, where you have angles and the sides opposite. So the sine of angle A over its opposite side is going to be the same as the ratio between the sine of angle B and its opposite side, and the sine of angle C and its opposite side. It's on your formula sheet. So if you think about it, you could label these angles however you want. Let's say this is angle A. That means this is side A. If this is angle B, that would make this side B. And then we have our blank like angle C and side C. Just think about the relationship between the angles and the sides that are opposite them. So what I see is that if I know the sine of A over A and the sine of B over B, they're going to be proportional. So I could cross multiply to find any missing parts. What you need to know to find the law of sines is not like all three of these, but instead just from two ratios, you need one side with an opposite angle that's complete and then one that's incomplete. So basically you need 3 out of 4. So if you consider this to be 4 pieces of information like A, B, and B, or maybe something like B, B, C, and C, you need 3 out of 4. So 2 angles and a side, or 2 sides and an angle that are opposite each other. So here we go. If I know that I have this pair here that's complete, an angle and a side, the sine of 95 over 10 is how I'll set up my B part. And then angle and side here, I have the sine of 35 over x. So having this in the denominator, honestly, I could write this upside down. It doesn't even matter. Like I can flip the whole thing over and that'll make my life easier. So I'm just gonna do that. So 10 over the sine of 95 equals x over the sine of 35. You know, that's how ratios work. So if it's this over this is this over that, you can flip them and the whole thing's still the same. The reason I did that is because it just makes it way easier to solve for x now, because all I have to do is multiply by this value on both sides and I'll have x by itself. So what I'm going to do is 10 divided by the sine of 95, and then I'll take that quantity times the sine of 35. Again, make sure that you are in degree mode. So 10 divided by the sine of 95. That's 10.038, etc. I take that value times the sine of 35. And I get 5.78 approximately. And my unit is centimeters. So what I've done is, by setting up proportions, even though this is not a right angle triangle, I'm still able to find missing values using this proportional relationship. Down here, you can see another example where I have 37 and its opposite side, which is x. And then I have 48, but its opposite side is blank. And then the angle that's opposite 18 is also blank. But do not fear, you can actually still use this, just sometimes you need to use the triangle sum theorem to get your opposite angle. So far I have 37 and 48 degrees. And if I subtract that from 180, I figure out that I have 95 degrees left over. So now I can set up my proportion because I've got my opposite sides and angles. Since I'm solving for x, which is the side again, you can say sine of 37 over x and sine of 95 over 18, or I can say x over the sine of 37, 18 over the sine of 95. Since it's easier to solve that way, I'm just gonna set it up with the sides on top. The only reason x is not by itself is because I'm dividing here, so I'm going to multiply by the sine of 37.
Hi everyone, my name is
Again, I want to divide this first and then multiply. So 18 divided by the sine of 95 is 18.0 blah, 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 and then multiply by the sine of 37. So I figure out that x is 10.87 meters. So that's the basics. Use the law of sines to set up ratios for angles and the sides that are opposite those angles so that you can find missing pieces in your triangles. So after I started looking at the classwork, I realized there are missing angles too, and we didn't do one like that on the notes. So let's set up one with a missing angle. So here I have a pair, and obviously I want angle B, and it's across from this. So I don't know this angle, and I have 23 here. So the sine of 44 over 17 equals the sine of angle B over 23. I'm trying to find this out. So if I multiply by 23 on both sides, I'll have the sine of B by itself, which gets me closer. So I'll divide this and then multiply by 23. Sine of 44 divided by 17. Make sure that this is closed up with your sine because you don't want the sine of something else. It's the sine of 44 divided by 17, and then I multiply that by 23. Okay, so I have about 0.939831, etc. The more accurate you can be with this, the better, because when you undo the sine function, the more specific this is, the closer you're gonna get to your actual angle. So to get B by itself, I inverse sine, because it's actually the sine of angle B. It's not sine times B. I'm not dividing by sine, I'm unsigning. So the inverse sine of this, second sine, 0.93, I'm just gonna type the whole thing in, 9831913 is, I think it's pretty much exactly 70 degrees. So angle B is 70. Yep, answer C. So it's going to round out to 70 degrees. To show you what I mean by you want to be exact as possible, if I do the inverse sine of, say, 0.94, let's say I rounded that to 2 digits, so 0.94. The inverse sine of 0.94, it's gonna give me 70.05. So like it still rounds to 70, but you can see how the decimal starts to be significantly different. So I always try to be as specific as possible when I'm taking an inverse sine.